This is a circle. This is a cyclic quad. When I extend one of the sides of the cyclic quad outside of the circle, I create an exterior angle. As long as this is a cyclic quad, this exterior angle will always be equal to the opposite interior angle. An exterior angle of a cyclic quad is equal to the opposite interior angle. This is Theorem 6. We are now dealing with cyclic quadrilaterals. So Theorem 6 states that an exterior angle of a cyclic quad is equal to the opposite interior angle. Here we are given point A, B, C, and D are points on the circumference. Whenever you have a quadrilateral, meaning a shape that has 4 vertices, that is inscribed inside of a circle, meaning all its 4 vertices touches the circumference of the circle, then that quadrilateral is cyclic. It forms a cyclic quadrilateral. So in this diagram, one side of our cyclic quad is extended outside of the circle, and it creates angle C1, which is an exterior angle. So we are required to prove that angle C1, our exterior angle, is equal to the opposite interior angle. We are required to prove that the exterior angle of a cyclic quad is equal to the opposite interior angle. In our previous video, we were proving that two opposite angles of a cyclic quad, when you add them up, you get an angle of 180 degrees, right? So since we know that this is a cyclic quad, we can use that theorem to prove that an exterior angle of a cyclic quad is equal to the opposite interior angle. But now we need to be careful which set of opposite angles are we going to use. If we use this one, then we have nothing to link them to angle C1. But if we use angle A and angle C2, we can link angle C2 with angle C1 by saying both angles are on a straight line. So we're going to use angle A and angle C2. We say angle A, when you add it with angle C2, you get 180 degrees. Why? Because these are opposite angles of a cyclic quad. Angle C2, when you add it with angle C1, it forms angle BC something, and it is a straight line. So both angles are equal to 180 degrees. So you say angle C2 plus angle C1, when you add them up, you get 180 degrees. Why? Because they are angles on a straight line. Now that we have two equations that are both equal to 180 degrees, so we can equate them and say 180 degrees is equal to 180 degrees. So now we have defined that the first 180 is equal to angle A plus angle C2. So we say angle A plus angle C2 in the place of the first 180 is equal to the second 180. We have stated that it is equal to angle C2 plus angle C1. And now when you look carefully at what we have, angle C2 is repeated. When you transpose one of them, they will annihilate, meaning if I have angle A plus this angle C2, then I transpose this angle C2 to this side and it becomes negative. And on this side, we're left with angle C1. When you have 1 minus 1, you get 0, right? So they completely annihilate, so they disappear. So we have angle A is equal to angle C1. And this is what they asked us to prove. We were required to prove that the exterior angle of a cyclic quad is equal to the opposite interior angle. This is the end of the video. We have proven Theorem 6. Thank you for watching.
It's easy to see when you look at me. If you look closely, Mystic don't back down. Subscribe to this channel if you haven't already, so that you can get that A in mathematics.
Leave a comment down below if you have a question. Mystic will make sure you get the answer.
Leave a like and share this video with your friends so that we can all be good. Thank you for watching.